Hello viewers, in today's class we are going to discuss an important topic from three-dimensional geometry, right? So here we have to discuss this problem of intersecting lines. So here we have to show that these two lines x minus 2 over 1, y minus 2 over 3, z minus 3 over 1 and x minus 2 over 1, y minus 3 over 4 and z minus 4 over 2 intersect, right? So we have to show that these two lines intersect. Now here let us first analyze these two lines. Now here the first line L1 is x minus 2 over 1, y minus 2 over 3 and z minus 3 over 1, right? Now we see that this line say L1, this line, it passes through the point 2 comma 2 comma 3, right? So 2 2 and 3. So this line passes through some point 2 2 and 3, and the DRs of this line, that is the direction ratios of this line L1, are 1 3 and 1, right? Okay, now come to the second line. Here we have L2 and we have x minus 2 over 1, y minus 3 over 4 and z minus 4 over 2, right? Now this line, say this is L2 and this line passes through 2 comma 3 comma 4, 2 comma 3 comma 4, and the direction ratios of this line L2 are 1 4 and 2, right? Okay, now here we have written these two results because we know that the equation of a line in 3 dimensions passing through x1 y1 z1 and having direction ratios a b c is given by x minus x1 over a, y minus y1 over b and z minus z1 over c, right? So we have compared this line with this one and we got these two results. Then we have compared this line with this one and we have got these two results, right? Now we have to show that these two lines intersect. Now we know that if two lines intersect, then they must be coplanar, right? So these two lines must lie on a plane, right? So in the same plane these two lines L1 and L2 should lie, right? So intersecting lines are coplanar, and we have to show that these two lines intersect, and in order to show that these two lines intersect, we can either show these two lines to be coplanar, or we can adopt a different method, right? So let us first take the coplanarity of these two lines L1 and L2. So once we prove that these two lines are coplanar, then these two lines must be intersecting, because these two lines have different direction ratios and these two lines are non-parallel, right? So non-parallel lines and lying on the same plane must be intersecting. So now viewers, the condition of coplanarity, of two lines L1 and L2 is given by the determinant, that is x minus x1, y minus y1, z minus z1, a1 b1 c1, here we'll have x2 minus x1, here we have y2 minus y1, and here we have z2 minus z1, and a1 b1 c1, a2 b2 c2, and this determinant should be equal to 0, right? So if two lines are coplanar, then the condition is given by this determinant should be equal to 0. So x2, y2, z2 and x1, y1, z1 are given by these 2 points, and a1, b1, c1 and a2, b2, c2 are given by these 2 direction ratios, right? So here this point is x1, y1, z1, and this point is x2, y2, z2, right? And 1, 3, 1 are the direction ratios of the line L1. So we have here A1, B1, C1, and here we have A2, B2, C2, right? So now let us calculate the value of this determinant. So we have x2 minus x1. So we have 2 minus 2, then we have 3 minus 2, and then we have 4 minus 3, right? And a1, b1, c1 is 1, 3, 1, and a2, b2, c2 is 1, 4 and 2, right? So this determinant is now reduced to 0, 1, 1, and here we have 1, 3, 4, and here we have 1, 1 and 2, right? Now if we expand this determinant along the first row, we have 0, and then we have minus 1, and we have 2 minus 1, and then we have 1, and we have 4 minus 3, right? So now this is minus 1, and 2 minus 1 is 1, and here we have 1 times 1, so this is minus 1 plus 1, that is 0, right? So we have got the value of this determinant as 0. So this shows that these 2 lines are coplanar, and moreover the direction ratios of the 2 lines are neither equal nor proportional. So these 2 lines must be non-coplanar, and hence they must be intersecting, right? Now we can adopt the other method, and let us see. Now viewers, in the second method, in which we'll show that these 2 lines are intersecting, what we will do, we'll find out the coordinates of the general point on these 2 lines. So for this, what we will do, here we'll take lambda, and here we'll take mu, right? So now from this equation, the coordinates of the general point are x minus 2 over 1 is equal to lambda, y minus 2 over 3 is equal to lambda, and z minus 3 over 1 is equal to lambda, right? So what we are doing, we are finding out the coordinates of general point lying on the lines. So this is the first line. So we have x is equal to lambda plus 2, here y is equal to 3 lambda plus 2, and here we have z is equal to lambda plus 3, right? Okay, now let us take the line L2. So here we have x minus 2 over 1 is equal to mu, then y minus 3 over 4 is equal to mu, and then z minus 4 over 2 is equal to mu, right? So now we have x is equal to mu plus 2, and then we have y is equal to 4 mu plus 3, and then we have z is equal to 2 mu plus 4, right? So the general coordinates of any point lying on this line L1 is given by lambda plus 2, 3 lambda plus 2, and lambda plus 3, and the coordinates of the general point lying on this line L2 is given by mu plus 2, 4 mu plus 3, and 2 mu plus 4, right? So now once we have obtained the coordinates of the general point lying on the lines L1 and L2, we have to show that the two lines are intersecting. Now here what we will do, uh, if the two lines intersect, that is L1 and L2, right? L1 and L2 intersect, then there must be a common point of intersection, which is this point P, right? Now for some value of lambda and mu, this point should represent the same coordinates, right? So I am repeating, if the two lines intersect, then we have a point of intersection P, and this point P lies on L1 as well as on line L2, and for some value of lambda and mu, these two coordinates must be equal, right, or equivalent, right? So these two coordinates must coincide for some value of lambda and mu. So if we compare the x coordinate, the y coordinate and the z coordinate, then we'll have three equations in lambda and mu, right? So we have lambda plus 2 is equal to mu plus 2, then we have 3 lambda plus 2 is equal to 4 mu plus 3, and then we have lambda plus 3 is equal to 2 mu plus 4, right? So now we have three linear equations in lambda and mu. Now we can simplify these three equations. So we have lambda minus mu is equal to 0. Here 2 and 2 get cancelled, and here we have 3 lambda minus 4 mu is equal to 1, and here we have lambda minus 2 mu is equal to 1, right? So now we have 1, 2 and 3, right? So now viewers, what we will do, we'll take any two equations out of these three equations. We'll take any two equations and we'll find out the value of lambda and mu. So here I am taking 1 and 2, and you can also take 2 and 3 or 1 and 3, right? So here I am taking 1 and 2. So lambda is equal to mu from the first equation, and if we take lambda is equal to mu in the second equation, we have 3 lambda minus 4 lambda is equal to 1. So we have minus lambda equal to 1, and we have lambda is equal to minus 1. So therefore mu is equal to minus 1, right? So the value of lambda and mu, both the values are equal, right? Now the next step is to substitute this value of lambda and mu in the third equation. Now if this equation number 3, it satisfies these two values, then we say that we have a common point of intersection, or the two lines are intersecting, right? And if these two values does not satisfy the third equation, then these two lines are not intersecting, right? So what we will do, let us substitute lambda minus 1, mu minus 1 here. So we have minus 1, minus 2 and minus 1, and here we have 1. So we have minus 1, minus minus plus, so we have 2 is equal to 1, and 2 minus 1 is 1, so 1 is equal to 1. So we see that lambda and mu satisfies the third equation, and hence we conclude that the two lines are intersecting. So this is how we prove that two lines are intersecting, right? So here we have adopted two methods. In the first method, we have shown that the two lines are coplanar, and moreover the direction ratios of the two lines are neither equal nor proportional, and hence the coplanar lines are or must be intersecting, and in the second method we have calculated the general point on the two lines, and we equated the general points obtained from the two lines, and we have got three equations. We took two equations out of the three, we solved them, we got the values of lambda and mu, and then we substituted these two values in the third equation, and if the third equation gets satisfied, then we say that the two lines are intersecting, and if the third equation doesn't get satisfied, then we say that the lines are non-intersecting. Right now here we can also find out the coordinates of this point P. So now we can substitute the value of lambda equal to -1 over here, or the value of mu equal to -1 over here to get the point of intersection. So P is now equal to, here we'll take lambda equal to -1, so 2 minus 1 -1 plus 2, then we have -3 plus 2, and then we have -1 plus 3, right? So this is 2 minus 1 1, 2 minus 3 -1, and 3 minus 1 is 2. So 1 minus 1 2 is the point of 1 minus 1, and 2 is the point of intersection of these two lines, and we'll get the same result from here if we take mu is equal to -1. So we have -1 plus 2 here, and then we have -4 plus 3, and then we have -2 plus 4. So we have 2 minus 1 1, 3 minus 4 -1, 4 minus 2 is 2, right? So we got the same point of intersection. So viewers, this is how we solved this conceptual problem from three-dimensional geometry.